All right, looks like people are coming in. Welcome everyone. Second keynote of the day about nerd sniping myself into a rabbit hole. I'll dive in immediately, but before we do that, I have a couple of disclaimers in this talk. First of all, you will see some bits and pieces of an application that I built for personal and learning use. I won't share it. If you ask, the answer will be no. It's all private. I'll not be putting that out. I will also be showing some brand names, application names, and so on. None of those are recommendations, so use that knowledge as you see fit, but I'm not recommending anything. All right, with that out of the way, let's get started. Somewhere last year in January 2020, my wife and I were looking for new living room speakers. Actually, when we built our house, we bought a couple of old PC speakers, put them in our living room, connected them to the TV, and we were using that as our stereo system for a long time. Now, we were also thinking about whether that was a good solution, and since we were doing lots of streaming from the internet, we were thinking let's maybe replace that with a speaker system that can actually stream from the internet, where we no longer have to connect things, so just some smart speakers that we can control using our smartphone, and then play music from Spotify, TuneIn, SoundCloud, YouTube, whatever. So we started shopping around, and we wanted to have 2 for the living room and 1 or 2 for our home office. And we found these Sonos speakers. Now, on paper, at least, they looked really nice because they had all of they met all of the checkboxes that we had. They had streaming, they had support for internet. You could essentially run anything you wanted to do there. Except the price points. We thought they were quite expensive for having just a smart speaker. It would almost be cheaper to get a good amplifier and then some other speakers as well. So we decided, okay, let's not go for these and wait until we see something better. Now, a little bit later, we were shopping around, or at least walking around in an IKEA, and we found that they had these Symfonisk speakers, and you see it on the left there. It's a speaker that has the typical Swedish IKEA design, very nice and very plain to have in your living room. And I started looking that up on the internet, and I found that they were actually Sonos speakers. So same software, same controller, same hardware, everything the same, except that everything was just a lot cheaper. So we didn't think a long time. We just thought, okay, since this already matches all of the things that we were looking for, let's just bring them home and install them in our living room. So we walked out with them, and as it goes in IKEA, we took the cardboard boxes with the product home. We read the manual. The manual actually said to sit in the sofa, so we did that as well. And we did that all, we installed them, and we installed the app on our smartphone as well. It was really brilliant. We were able to tune a local radio station on TuneIn. We were able to play some music from Spotify on those speakers. Everything was in sync. We had stereo sound, really cool. If we would walk up to the home office, which is on the 2nd floor in our house, everything would keep playing, and we would hear the audio everywhere. Really so good. Just use your smartphone to turn up the volume or turn it down a little bit. Amazing. We were kind of in a honeymoon phase by just using those speakers. Really cool. What we also do is we stream a lot of music from a website that is on the internet, and you may recognize the logo there. It's YouTube. But we do a lot of streaming there because a lot of music appears there first, or there's some extended versions or remixes and things like that. So we wanted to play those on our Sonos system. Now, unfortunately, it seemed so that we could not use the app on our smartphone to stream music from YouTube, or at least music that is in a video, to our home speakers. That's not super smart, right? So we were kind of getting out of our honeymoon phase in that at that point. Now what do we do? So, and this slide is very blank and very undesigned, because this was the feeling that we really had. We felt empty. We thought, okay, we bought these speakers, and now what can we do? So I started looking on the internet a little bit, and it turns out that the 2 companies are fighting a little bit, and there's patents and stuff. So there's a good reason for them to not offer this functionality out of the box. But for us as consumers, I was very disappointed. No way around it. nothing to solve this. So we started looking at how we could actually play music from YouTube on that Sonos system. And we found this application called Sonos-Tube, and I'm not sure if this is actually even a legal application, but it is in the Play Store that allows you to do all of this. Except it was $3, which is ridiculously expensive if you just bought new speakers. But also, since the fact that it is borderline illegal, I would think, we decided not to install this one because probably after a week or so it would not work. I haven't tried it since, but there were some reasons for us to not go with this application. Now, we still had that issue that we wanted to play music on our speakers from YouTube. So why can't we just share music from an application on our speakers? So I started looking at the documentation on the Sonos website, and I saw that those speakers can actually do a lot of things, and they can play MP3 music, they can play MP4 music, and so on. And I was thinking, all of those videos that I upload to YouTube are MP4. All of the other videos on YouTube are probably also MP4. If that is supported by the Sonos system, is there a way that I can figure out what the URL to a video is and stream that thing on those speakers? Good question. And this is where the nerd snipe came in. For those not familiar with the term nerd sniping is the act of presenting someone with a time-consuming problem appealing to a person's obsessive tendencies. So this was the perfect nerd snipe. I was thinking, how hard can it be? I wanted to solve this problem for us and be able to play music on our speakers. So it's kind of like a self-nerd snipe that we achieved, where I dove in and started researching. So in terms of research, I started thinking, what would I need? I would need a way to connect to those speakers and be able to control them, give them a URL to an online video somewhere. I would have to be able to find that MP4 URL of an online video and play that, send that URL to the speakers, and then all that would be left is enjoying music. Again, how hard can it be, right? So I started looking around, and before building an actual app, I decided to just look around and shop around for libraries and test some things. And I found this SOCO, or Sonos controller library in Python, that you can use to connect to one speaker to a set of speakers and so on. And you could send it URLs that it would play. You could turn up the volume, turn down the volume. So all of that was there. So I went looking through the source code, installed a Python runtime on my machine, and built a very small sample code to connect to one speaker at an IP address in our home network and play an MP3 from a server. Actually, my local machine, I just hosted a web server with an MP3 on there and sent that off to the speakers. And very promising, all of that worked. So I thought, okay, this is awesome. I have a library that can send stuff to those speakers and play whatever I send to those speakers. So if I can now replicate this at a later point, I can probably make this work from an app as well. So the next thing that I did was getting the MP4 URL of online video. Apparently, YouTube has this identifier of the video in the URL that you can use, and you can access it from there. And there's another URL, get video info, that's using the same video identifier will give you back all of the metadata for that video. Now, this is very unclear, but it's really like a query string with various variables and various values. And somewhere in there, there is actually some JSON data as well. So if you look at the JSON data that you get back, you will see that there's a streaming data object in there that gives you an array of all the different audio and video formats that the video has. So just parsing that and going through that array of formats, it is actually possible to figure out what the MP4 URL to a certain video is. And using the MIME type, you can even select the one with the best quality or the lowest quality, depending on what you want to do there. So again, very promising. We figured out that I could get the MP4 URL from YouTube. And I did some more reading. I actually found a friend of mine, Alexei, apparently had written a blog post that talks about this entire reverse engineering of YouTube and figuring out the metadata. And in this very, very long blog post, if you look it up, it's a very long blog post, you'll see that YouTube also create signed videos. So for some videos, typically by record labels and so on, videos will be signed, and you will actually have to parse the video player JavaScript code to get the logic to decrypt that signature in that token to actually be able to play whatever is on that URL. So I decided, okay, I can get the metadata manually using this video endpoint, but luckily for us, we're living in a world where there's a lot of scripts and libraries that we can use from whatever programming language where someone already did the hard work, and you can just consume it to get the video. In summary, I was able to get the MP4 URL using yet another library. So the next thing that I tried was the same thing that I did before, taking that Python code and running it using a URL that had this MP4 in the URL. Actually, a proper YouTube URL to check if the Sonos speakers could play them when I send it to them. So in terms of a test case, I was expecting to hear audio. Unfortunately, I was not getting any audio. And actually, that's also a little bit of a lie. Actually, when I sent the URL to the speakers, it would say for just a second, and that was it. So not real music, just a small pop, and that was it. So now what? Troubleshooting. Now, I mentioned that the talk title is actually nerd sniping myself into a rabbit hole, and I thought as a troubleshooting background, I'm going to look for a rabbit hole that is royalty-free. Unfortunately, the irony of that is that finding a license-free picture of a rabbit hole turned out to be a rabbit hole in itself. With that side note, let's talk a little bit about some troubleshooting steps that I tried. So after Googling a lot and using various search engines, I found that all of those speakers actually have a hidden web server that you can just access whenever you're on the same network. So if you hit the speaker port 1400 and you go into /status or support review or tools.htm, you can actually do pings and trace routes. You can get the supported audio formats. You can look at the video and see, or you can look at the supported codecs. So all of that information is there. And essentially the only thing that I could figure out was that I could ping my gateway in the local network from this web server, and that the website was correct and that the supported audio formats of my speakers did support MP4. So what's next? Well, I thought maybe it's that SOCO library. Since it's Sonos, but it's an IKEA speaker, and maybe it's not 100% Sonos, maybe something is wrong there, and maybe those 70 contributors of this SOCO library are wrong. The official application can send a stream to the speakers. So what if I listen on the network and see what the request looks like to validate whether that library is actually correct or not? So I decided to do that. And I started looking into how I could sniff the network and see what is going on there. And I found that you can use Wireshark to sniff traffic that passes your computer's network adapter. And unfortunately, I also found out that traffic did not pass my computer, because my phone is on Wi-Fi, speakers are on Wi-Fi, my computer is on Wi-Fi, but my local access points in my home network behave like a switch, so they don't see traffic that is not intended for them. So damn it, how do I solve this? Then I started thinking, I have those Unify access points that serve my Wi-Fi. They are Linux or Unix based. So I could go on there and use the TCP dump command from a shell or from a terminal, and then see what passes the actual access point there. So I did that. And while doing so, I found out that on Windows 10, I can use the Windows subsystem for Linux, SSH into my access point, run TCP dump, and then pipe all of that data back to my Windows 10 hard drive. So a very long command where I can actually connect to my access points, run TCP dump, and say that I'm interested in capturing all the traffic that goes over the Wi-Fi interface, and then decide which IP address that I want to target, and then pipe it back to my local computer. So really cool, I did that. And the really nice thing about this is that that dump file can also be read by Wireshark. So I looked into that, opened it up. I had a little bit of trouble figuring out what data I was actually looking at here, but at some point I found in those requests in Wireshark that there was an actual payload. And in that payload, I was seeing that I was sending our device an actual radio station URL or an MP3 URL, and that the payload there is actually SOAP. So yes, your fancy modern Wi-Fi speaker probably uses SOAP as a transport mechanism. So beautifying that a little bit, you will see that the SOAP payload is actually sending some payloads to the speakers, and the payload consists of the URI that it has to play with a specific protocol prefix there, a title, a description. If you want to send it an image with album art, you can do so as well, which is pretty cool. Turns out, looking for the different namespaces in that XML document there, that this is just universal plug and play. So apparently, if somewhere 15 years ago you had one of those early network speakers, it's still the same SOAP payload, still the same protocol. So that actually works. Now, the good thing is that I found this SOAP payload. I knew the URL or the IP address of my speakers, so I decided to try things. And I tried MP3s and MP4s on a server somewhere, and essentially the same results. MP3 worked, MP4 did not work. So in summary there, that SOCO library worked just fine. It's just the MP4 that doesn't seem to work. So now what? At this point, I was really down the rabbit hole and thinking, well, I have to do this now. I went so far already. I have to finish this and make it work. So I did. I started looking into containers. Not Docker, not Kubernetes, but containers in terms of the MP4 file formats. Again, I brought up the Sonos documentation page and found again that support audio formats table that is there. And in there, I found that MP4 does not play radio stations from the internet. I can play that from my local library. I can play that from my Android device, but not from radio stations on the internet. But then further down the table, I found that AAC formats is supported as an internet radio station. So this means that if I could convert my MP4 to AAC, I would probably be able to play this. Even better news, in a lot of the MP4 formats out there, you'll actually find that the audio track in those files is already in AAC format. So I decided, aha, I'm figuring things out here. If I take an MP4, extract that AAC format audio track, and then send that off to the speakers, maybe this will all be solved. So I did that using the Swiss Army knife for audio and video, FFmpeg. And there is a command that you can run to extract that AAC audio track. And I did that, generated an M4A extension, sent that to the speaker, and decided to run my test again. Expectation was audio. Actual result was nothing. Not even that pop that I had before, just nothing. So at this point, I was very, very, very close to giving up. Now, unfortunately, I already had done a lot of Googling and a lot of searching, and somewhere on page 25 of the search results, I found someone with the fantastic name Dead Foods. It's actually pretty cool because the zeros have eyes there, but who wrote a blog post doing essentially or investigating essentially the same things that I was investigating. So I decided to look up this person on Twitter, send them a direct message, and start chatting about what they have tried, what I have tried, and so on. And at some point, this person said to me, yes, it's MP4. There's an AAC track in there, but the AAC track is not in the correct format. You'll have to convert it to ADTS. ADTS? Yeah, he said, every atom needs a header in every frame in that ADTS format. And I was like, what are you talking about? Now, luckily, somewhere in the documentation of FFmpeg, I found that you can actually extract AAC in ADTS format out of an MP4 file. And I tried that and tested if that worked on those speakers. So again, I did my tests. I expected audio and it worked. I got audio. So no longer grumpy cats, actually happy cats. So all of the pieces fell in place. Everything kind of works. I could get the URL. I could send it to those speakers. It even played. So now was the time to make it an actual application on my phone. So I thought, what if I can create an application that works from the YouTube application, where I can click that share button, that would then call my application, send the URL of the current video to my application. My application would then get the metadata for for the file that I wanted to play, do that conversion to ADTS, then run a reverse proxy on my phone, and then send that off to those speakers. That sounded like a plan. The only thing was I had no idea how to go about this. So I installed Android Studio, and I knew nothing about Android development or mobile application development, but I saw that there's this main activity thing, which is essentially your main screen that you can do. And I found a manifest somewhere, and I thought, okay, this manifest is probably what I should be filling out first. So I started Googling again and found that my main activity is there. So the application knows where my application starts, and I could add intents. And the intent that I wanted to add to my application was that other applications could send data to it, and I would filter that data by URL. So my application would only allow other applications to send data that had YouTube or youtube.com or www.youtube.com in there, and get that data from there. I also looked into that actual main activity and added one additional line of code to get the URL from the text that was being sent to the application. And also that seemed to work magically. So I was really super happy that after an evening of hacking in there, it all worked, and I actually got a URL into my application. Not yet there, but still this was better than expected because I thought this was going to be another rabbit hole. Running a web server on your phone apparently seems quite easy as well. What you'll have to do in that manifest is add the fact that you want to run a service on your phone, much like on a web server or on any other OS, and then implement that service. And the service has an onStart command and an onDestroy, where you have to hook up the server that you want to run. So what I thought, I'll run an embedded server using a Kotlin library called Ktor, run it on port 36362, and then support getting MP4 URLs in its routing, write code for that, and just start and stop based on whatever was coming in there. Next up was, so this all worked. I actually had a web server running on my phone, but then the next thing was getting FFmpeg to run on my phone as well. So I did some more searching. There's actually a very nice package search that you can use to find libraries that you can use in Android and in Java and Kotlin. And I found that you could run FFmpeg on your phone. Sounds promising, but it has a downside. Some of the songs we play from YouTube are live sets that typically take 1 or 2 hours. And if you would use FFmpeg, that would mean that we would have to download 2 hours of music and video onto our phone, run FFmpeg, and then send it off to the speakers, which means that we are wasting disk space on our phone, but also means that we will have a significant delay between sharing and actually playing it on the speakers. So I kept chatting with that dead food person, and he mentioned, well, in the AAC audio, you will find that all of the segments in that format actually have a header that says, hey, there are some audio samples coming, and then the data for those samples follows. And then there's going to be another header and more data, another header, more data, etc. So this is a thing that the speakers did not support, but he told me if you rewrite that to have a header for every single sample that is in there, so just a header and immediately the data for one audio sample, you're done. And again, I was baffled a little bit. I had no idea how to go about it, but I found yet another library, MP4 parser, that I could use to open up the MP4 stream. I spent a couple of nights on this one because it's not as easy as I expected, but there's some wiki pages that give you the actual format of the header that you have to send out. And using that library and some custom codes to write out this specific header in that web server, things started to work. So without further ado, and I don't think I have audio, so you will trust me that this actually plays audio, but here is a demo of the application in action. So on the left, you will see my screen. On the right, you will see Happy Maarten if this all works. So in the YouTube app, I could share. It would show my YouTube to Sonos app, which would open, which would then scan the network to see whatever speakers are available. Takes a couple of seconds because it's all UPnP and it has to do a couple of other things. I could then send it to my application. and then things would start playing. The audio is now actually playing, not sure if you can hear it. And in the Sonos app, I could even see the title coming from YouTube, description and the artist and the album art. So really, really, really happy with this. And in essence, it works. Really cool. I spent way too much time on this, but it works, which is really cool. Now you may be wondering, why would you bring this as a keynote presentation? Well, it's a nice story, of course, but I think the moral of this story is that learning as someone in IT is very important. It's really important to explore technology and start troubleshooting things that don't work, because you gain experience that you can also use in later projects or actual customer work that you are doing. Also, help and be helped. If you leave breadcrumbs for those who are on a similar path as you were in the future, you will be able to figure out things because someone left those breadcrumbs for you, or you are leaving them for someone else. If you do something like this, write about it, give presentations about it, anything, spread the word, because someone at a later point will be on the same path. If you just tweet about it or do a TikTok or a fleet or whatever, it will disappear in the vast mass of everything that is on the internet. Write about it, blog about it, and leave those breadcrumbs for those who follow your path later on. And also very important, you can do it. I had no idea about MP4 formats. I had no idea about network sniffing. I had no idea about Android application building. But if you set your mind to it and spend some time, you can get those things done. Yes, it may cost time. Yes, you will be frustrated doing so. But if you set your mind to it, you can learn and work with others to help people learn as well. With that, thank you and enjoy the rest of this conference where you will follow the breadcrumbs of others.